You're probably like a developer or something. I mean, I hope you are, because then otherwise it's like, you know, this won't make sense. So no, if you're looking for like, you know, Fortnite V-Bucks codes, not gonna lie, this is not the place to find them. Today I'm gonna be talking about Yucon Framework. Now, Yucon Framework is a big beefy framework I made a while back, but unfortunately it's very hard to understand for those who, you know, don't have like years and years and years experience with Lua. And since I've been making a lot of updates lately, I've been getting more invested in this framework. I thought, you know what, why not? I hope you like subscribe or something, you know, because I make tutorials, but I'm not gonna beg you for it, so whatever. Let's just go ahead and get on with it. Okay, so first things first is this link will be included in the description. It is a link to the dev forum where it tells you how, basically gives an overview of how to install it and, you know, some documentation inside. Okay, so over here, you're gonna see this link and it's gonna be this plugin. Go ahead and click install and it's gonna open up Studio, and then basically you're gonna install it. And you probably had a message right here saying Yucon Framework was installed. Let's make a new game with it, huh? Somewhere up here, you should see import framework and Yucon editor. If you try to click Yucon editor without actually importing the framework, you'll get this error message, which is totally okay. So go ahead and import the framework. Now, what you're gonna notice is you're gonna see these inserted to server script service, these inserted to starter player scripts, and these inserted to replicated storage. Now, it's important you don't delete any of these. Okay, so when you open up the editor, you're gonna be prompted with something like this. There's a bit of a bug where sometimes this doesn't show immediately, and everything will show once we make a script or a plugin. Now, you'll see script name is plugin name in these two text boxes here, and you see client server shared. If you type a name in here, and we're gonna name this test script, and we click client, this makes a client-sided script. And it's the same as making a local script pretty much. However, this is run with Yucon Framework, so of course it's different. And you're gonna be prompted with 4 methods here. You're gonna have preload, render, step, and start. Okay, and if we click server, we will see that now we're prompted with a server script named the exact same, and then we will see it right here as well as the client right here. Now, if you're to open up scripts right here in server, you'll see that there's the server test script, and it looks like a module script, but treat it like a regular one. And here is a regular client script. Okay, so now we have plugins, and treat plugins like you would normally treat a module in Lua. So for example, we'll name this module code, and we'll put it in shared so that both the server and the client can use it. Okay, so we can go ahead and close up this editor by clicking that. We can, you know, you can always reopen it doing that. And I'm just gonna go ahead and reopen it. On the side, you'll see all of these names, and these are plugins and scripts, and you can click on any one of these to open them up. So even if I close these out, I could still open up server script or the server test script. Alternatively, you can just go on here and edit it. It's totally up to you. You see all this documentation. It's probably a lot of information for you. Don't worry, I'm gonna break down the basics. Now, basically what happens is with all Yucon scripts, first, Yucon will do preload for all the scripts. So nothing else will happen in here until we have preload for every step. Is what happens with every run service.heartbeat, and I'll represent that in just a sec. And start is your main script code. You know, that's what actually starts the script. So if I do a print A and a print B here, we're gonna see that A will print before B because, you know, that's a preload. And we can see that's the case right there. Now, if I print step, then I'm going to see that step is going to be printed about every 1/60th of a second. And you can see that's how it is right there. Okay, so by the way, when you see delta in here, you can print delta or really do anything with it, but delta tells you the time passed between heartbeat frames. It's not always the same, so be careful with that. Delta is a very handy dandy number if you're trying to do precise calculations. If I type in delta, it'll tell me the time passed between every frame. And you can see it varies anywhere between 0.018 and 0.017. Sometimes it gets as low as 0.015. Just do that. I can make another server script real quick to show you what I mean with the preloading and start system. So another one, another A, and we can go ahead and do another A, and another A should be printed first, and then another B and B should be printed next. Test it, you'll see that another A and A always are going to be before another B and B. And that's just because they're preloading. Same thing is for the client side. Whenever we have preload, step, and start. However, we also have render, which serves as the same thing as step, but basically goes every time your frame, every time you get a new frame. So let's say you have 60 frames per second. This is called 60 times a second. If you have 10 frames per second, you know, you got a potato computer, then this is gonna be called 10 times a second. So that's why I use that delta. The lower your frame rate, the bigger the delta. Keep that in mind. Now, one of the purposes of Yucon is to prevent the use of while and wait. Now, the reason those are bad practices, well, I mean, you can go to the dev forum and there's a lot of stuff on that. So I'm going to show you how to avoid using wait in Yucon. And there's actually something very handy called the thread handler. Now, thread handler is a plugin. If we look in the Yucon editor, we'll see thread handler. If we open that up, it will give us all the documentation for it if you're ever curious. For now, we're gonna make it wait 5 seconds and then print So if we open up test script, which again, you can just go to Yucon editor, test script. Let's go into start, okay? So let's say B, and then let's go ahead and get the thread handler. Now, one of the things you can do in Yucon is get plugin. Now get plugin gets a plugin. Now, thread handler is a shared plugin, so it can be accessed by both server scripts and client scripts. If I do local thread handler is equal to self plugin, and then we have thread handler, then that just got the thread handler thing. Now we now have a variable that basically is like, you know, treating this as a module script. However, now we can only access this in start, which is unfortunate. By the way, if you're curious, self means Yucon. That is the Yucon framework, and self can only be used in start, step, preload, and all of those things. Trying to type self outside of here is going to get you that red line because, you know, self is not a valid thing. Okay, so let's let thread handler be accessed by both step and preload. If we were to do this, we can go ahead and do local thread handler, and then in the preload we can do thread handler equals self get plugin thread handler, and now this variable is equal to the thread handler. So that now we can access in start and step without having to make more variables. Now in step, go ahead and type thread handler pop, and I'll explain why in a sec. And in test script, let's do thread handler wait 5, and this is gonna wait 5 seconds, and it's gonna be pretty dang accurate, I'll tell you that. And we're gonna type waited 5 seconds. Now we run this and we have A, B, and then waited 5 seconds. Now the reason we have pop is because, well, I mean, thread handler just wouldn't work without pop. If you use thread handler, you need to do thread handler pop every step or every render. Do not do it more than that. If I were to remove thread handler pop, we would get an infinite wait, and our print it would never print. So make sure you have that pop in there. And don't put it in start, don't put it in preload, because we do need that in step. Okay, so let's just go ahead and make some basic games. So I'm gonna go ahead and make the map real quick, and I'll get back to you as soon as I'm done with that. Okay, so we have a basic map. You know, I just put some concrete trees in here, you know, set the theme and a grid base plate. So let's just go ahead and make a game where basically there's gonna be bricks falling from the sky, and you have to avoid them. And, you know, once you get hit by them, it just, you die, and then it resets, I guess. Now this is gonna be basic. You can, on your own, you can make it get progressively harder and make the bricks reset. But for now, we're just gonna do something very basic so you can get the idea of Yucon Framework. Okay, so first let's open up Yucon Editor, and let's just, I deleted the scripts that I made before just by going in here and deleting them. So let's make a script in the server called server script. Okay, so now we have this. Okay, so first let's make a function that basically makes a part that's gonna fall from the sky. So we're gonna do local function make part. Okay, now the space plate is 100 by 100, so I'm gonna say, you know, spawn a random vector that's contained within 50, 50, 50, 50, and I'll explain that in a sec. Okay, and let's make the part not collide, because we're gonna basically move it on our own with the step. Okay, and let's go ahead and make the brick color dot random, and we're going to do part dot size because it's vector 3 parts material. Now this is my code to basically make a random part that spawns randomly positioned in the air with a random rotation, and it's totally up to you what you do to make that part. Go ahead and make a blank array. An array is a type of table, remember that, so we can do all parts equals, and then just do a blank table. Okay, table insert all parts, and we're gonna insert. Now the thing is this is a bit inefficient, because we already have a preload, but we're trying to preload the function. So basically we can fix that. Okay, so I have local make part up here, and then when it's preloaded, it makes the function, which means now we're gonna leave it up to the preload to actually do that preloading. Okay, and then let's go ahead and do local current game time is equal to 0. Now basically, what we're gonna do is every second, we're gonna make a block spawn. So in the step, we're gonna do current game time plus equals step, or double. So let's say 1 heartbeat is passed. That means 1/60th of a second. That means current game time is gonna be about 0.01 second. And we're gonna basically make it where every second a block spawn. I'm gonna say if current game time is greater than or equal to 1, then we're gonna go ahead and make part. Okay, and then below that, we're gonna say for index comma value in pairs, and then we're gonna do all parts because we're gonna make all the parts fall. We're gonna do value.cframe is equal to value.cframe minus vector3.new. I'm gonna do 0 delta 0. Now that's basically gonna do 1 stud per second, and we're gonna fix that and make it faster in a second. For now, let's make a variable called speed, and let's go ahead and set that to 0, or set that to 1. Actually, I'm dumb. And do times speed, and we're gonna see what it looks like in just a second. Oh wait, I forgot something. Oh, oops, we gotta part.parent equals workspace. Oops. Okay, so we now see this massive parts spawning, and it seems that they actually are spawning once every 1/60th of a second, which is a bit of an issue, and I'll explain why. So basically, we forgot to reset the current game time. Now the reason I purposely included this mistake is because this is a very common mistake. Hint, I didn't actually accidentally do this. I'm completely improvising this. All right, so current game time, let's set that to 0 before we make a part, so that way we truly reset that timer. Okay, so now we have a part generating every second of random size and random rotation. Not gonna lie, they're falling pretty slow. I'm not sure about you, but I think they're falling pretty slow. Okay, so how about workspace.gravity? Because you know, just try that. And now we simulate the parts being, simulate them being fallen without actually having to use real physics. Now let's go ahead and make a part spawn every half of a second. Okay, so now we have the parts spawning every half of a second, but they spawn a bit too low. So let's go ahead and increase that. And then, this is just, trial and error. Change that to 500. Nice, now they spawn way up there, and we just have that. Let's take it a bit further. So right now, our parts don't despawn, which means it's gonna get laggier and laggier over time. Don't worry, we can fix that. So we can say if value.cframe.position.y is less than or equal workspace dot fall part destroy height, then value destroy. And to make sure our table stays cleaned up, we can do all parts index equal to nil. Now I'm gonna go ahead and put that before value destroy, just to make sure we don't cause any issues. Now we have those parts spawning, and they should despawn when they get down there. Okay, now let's make the parts actually kill. Now this should be more familiar to you when we do part.touched connect function. So let's go ahead and make a basic kill function inside of the part. Okay, so now we have all of the parts, killing anything. All right, so basically we gotta avoid it. Oh boy, they're falling. Not gonna lie, they're pretty good at falling. So if I try to touch one of these parts, we can see that it does indeed kill it. And there we go. That's a basic thing in Yucon Framework. Now, if you want me to make more videos on this, I could definitely do that. It's totally up to you guys. Let me know. You can let me know in my Discord, inside of the dev forum, or in the comments below. That's totally up to you. If you enjoyed this, cool. That's actually pretty good. That means I'm doing my job right.